Okay, test, test. Can you guys hear me in the back okay? Okay, great. So let's go ahead and get started. I'm Phil Naparolsky, and I'm a program manager on the Windows ecosystem team here at Microsoft. So part of my job description at Microsoft is I work with people like you, external partners, who are developing things using DirectX, using graphics. So this is a culmination of all the things that, all the questions that I've gotten. It's mostly going to be a high-level, fundamental kind of talk on the DirectX side and on the C++ side. But it's going to give you enough information so you can go out to these other talks and these other resources that I point you to and build a great Windows Store C++ and DirectX app. So here's how I'm going to structure the talk. I'm going to give you the fundamentals of using DirectX with your Windows Store app, and how you can use XAML with DirectX. Then I'm going to talk about the fundamentals of C++. Some things have been updated to make your life easier as developers in the Windows Store. And then I'm also going to go into the Windows Store features. How do you do live tiles in C++? How do you do host notifications? Things like that. So let's dig in. So you're at Build, and I'm sure you've learned by now that we really give developers choice in their choice of development language. So whether you want to use HTML, JavaScript, CSS3, C#, Visual Basic, XAML, DirectX, the C++, even C# using third-party libraries, you have all that in front of you. But if you're at this talk, I hope that you're mostly interested in these bottom two choices, and especially using C++ with that. So let's dig into the fundamentals of how you can use DirectX in your Windows Store app. There's three main things, well, kind of four main things, that pretty much all DirectX apps will use, especially in Windows Store apps. And I'm going to show you how to do that with some code. So there's the Direct3D device and context. There's setting up shaders. And in the majority of cases, you'll have your swap chain that you'll set up. So the Direct3D device is initialized using this function call, the D3D11 create device function call. What that gives you out is it gives you out the device structure. It gives you out the context structure. And you can use the device structure for things like doing initialization, creating your shaders, your pixel shaders, creating your vertex shaders, all that good stuff. But when it comes time to actually binding something to the pipeline, you'll use the context that you get from this function. And then also in this method, you get back the feature level of the machine that the app is running on. Now, if you want to learn more about feature levels, there's a great talk that I'm giving tomorrow night that you can check out. So I won't have time to go into that. But that gives you kind of just an understanding of this fundamental API call. Now, what are shaders? Some of you may know what a shader is, but if you don't know, that is essentially a chunk of code that you write using a high-level shader language, or HLSL, as we like to call it with DirectX. You're going to use that language and write some snippet of code, okay? And that is going to be the code that you use to do an operation on every vertex that you pass to the graphics card. Or put a different way, from a higher level, that is the code that's going to run on your graphics card. So when you're actually setting up your shaders, here's kind of how you do it. You define what's going to be the inputs into the shader, specifically into the vertex shader. So now imagine you have this scene with all kinds of vertices. Okay, you have millions and millions of points. Okay, and you want to do some processing on that and eventually get that displayed on the screen. Well, in this example, each point has a position and a color associated with it. And what I'm not showing you here, but I have in the bottom with the create input layout call, is you're going to define a structure called the layout description that actually says, hey, there's a structure that has 3 floating points that represent XYZ position, and then 3 floating numbers that represent XYZ color. And that go in layout description. And then to actually create the vertex and pixel shaders, you're going to use these API calls. Now, then the final piece of the puzzle that you'll see as a fundamental thing in your DirectX applications is the swap chain. Now, what's a swap chain? Well, a swap chain is, well, let me take a step back. If you just drew everything using DirectX right to the screen, as I'm seeing it, you're going to notice what we call like tearing and that kind of thing. What the swap chain has, it has a buffer that's on the front that represents what you're actually seeing, and then it has a buffer on the back. The back buffer is what you're actually going to be drawing to. Okay? So then, when you do an API call present, that back buffer will swap to the front. And so this will happen over and over and over again. And the structure that actually does this for you, this double buffering, is the swap chain. So now, if you're not using XAML with your application, with your Windows Store app, here's how you do it. You'd use the API call create swap chain for core window. And the only thing that you really have to know about is the swap chain description, the D3D device that you got from the D3D11 create device call, and there's this little thing called a core window, okay, that you're also passing it. Now, if you've heard about the core window from other talks, that's great. If you don't know what I'm talking about, wait 2 slides or more slides, and I'll tell you. Now, that's without XAML. With XAML, the only time you're going to use a swap chain is if you have this thing called a swap chain background panel. Now, again, if you haven't heard about this from the other talks, wait 2 slides. You'll hear about it. But essentially, when using XAML with DirectX, you have all kinds of scenarios you can utilize DirectX with. But the main one is the most common I'm seeing when dealing with partners and working with partners is the swap chain background panel. And it's real simple. Compared to the core window, there's only one parameter missing, okay? Because with XAML apps, you no longer have a notion of a core window. You have the XAML elements, okay? Since it's XML, it's very cool. And then down here, afterwards, that's when you'll actually bind your direct 3D device and context to the XAML element, the swap chain background panel. Okay. All right, so I've talked about those 3 core things, those core 3 DirectX things. Now I want to talk about the scenarios where you'll use XAML, if you want to. So I'm going to answer these questions. What is XAML? Why would you use XAML with your DirectX app? Now, XAML is essentially a toolkit, for those who don't know. It's a language that allows you to have all these controls essentially with 1 or 2 lines of declarative code. So if you want to make an app bar, that's super easy. You just say app bar in those little angle brackets, and boom. But there's some trade-offs if you decide to use XAML with your DirectX app. Some of the trade-offs include if you want more flexibility with your DirectX app. Maybe you want pixel-level control with your app. Well, then you would want to go pure DirectX. But if you want something that's quick and easy, something to just get you going, and something that, by the way, conforms to all the Windows 8 design guidelines that we provide, you can just use XAML, and it works great right out of the box with your DirectX app. And of course, some of the other considerations you have to make. Do you know XAML? Do you want to learn XAML? Okay. If you're a pro at DirectX, why, maybe just go with the pure DirectX C++ route. Okay. But the key takeaway from this slide, I want you to kind of solidify in your brain, is that you need to make this decision up front. It's much easier if you don't make this decision up front. It's harder to add XAML later on than it is to just start with it. Okay. So let me say that again. Make that decision up front. Do you want to use XAML with DirectX? Do you want to just do DirectX C++? Okay. So just to show you a little bit of a comparison, I'm going to switch over to my laptop here. And I'm going to show you an application that utilizes just DirectX and C++, no XAML. And that application is called FreshPaint. Maybe you've seen it in other demos already. But I'm showing it here. It's this great application where you can use your fingers to paint. And clearly, I'm not a painter. I've practiced this demo a couple times. Excuse me. But what is important is when I swipe up from the edge, or when I right mouse click, or when I press the keyboard combination that brings up the app bar, what you get is this rich user interface. Okay? And you can tell that this is done with DirectX. With XAML, I mean, you get something that's, it conforms to the Windows 8 guidelines and it's great. But it's a little harder to do controls like this that are interactive. Well, they're interactive, right? But something that has this sort of flexibility. Another example is AccuWeather's app. AccuWeather, as maybe you can tell by the name, is an app that tells you the weather, right? But it's not your mama's weather app. In the back, it has a swap chain background panel. That's a XAML element. And they bound DirectX to that XAML element. So they can show this cool rainy effect, this cloud effect. And this is awesome. They made their app stand out by using DirectX. But up front, you can see this is all XAML. Okay? So, and it's fast and it's fluid. And it's great. So those are really the two options. Do you want to build an app like FreshPaint, where you have your app bar where you can mix colors and do all this cool stuff? Or do you want to use XAML for maybe your front-end user interface? Let me switch back. So that gives you a little bit of an overview of the difference. But there's other scenarios, and I'll talk about those other scenarios where you'll potentially use XAML with your DirectX app. So as I showed you, AccuWeather did a great job of using the swap chain background panel. Okay? And that's going to be your root element of your XAML document. And you can have all this other XAML stuff that goes on top of that. And that allows you to do things like having the graphics in the background, and then having XAML elements represent your UI in the foreground. The other scenario where you might think about using XAML with DirectX is, let's say you're writing an app, C# or C++, and it's a database of 3D models. Okay? It's maybe something that's populated from online by users of your app, and it's something people can go in and get ratings on their models, do all this cool stuff with their models, and get people socializing about these 3D models they've created in their favorite program. Well, now, what if you want to just display inside of a XAML element that DirectX that draws their model for them? Well, you can do that using the surface image source. Oh, and by the way, we have a great sample that helps you out with this. There's a couple caveats here. This is one of those scenarios that does not have a swap chain associated with it. So that means if you want to do stereoscopic 3D, you need to use a swap chain background panel. If you need to do things like that require quick updating, that require that double buffering, you should go with the full screen swap chain background panel. But this is a great solution if you just need to do something that's inside a XAML element that is going to be just kind of viewed. And I'll be taking questions towards the end, so feel free to write them down as I'm talking. And then the final scenario where you can use XAML with DirectX is, let's say you have this huge image. Bing Maps utilizes this scenario. They have this huge image that represents the map of, say, the world of the United States. Well, now you want to view it one tile at a time, and you want that to be fast. Oh, and by the way, you don't want to create everything from scratch using DirectX and C++. Well, you can use this thing called virtual surface image source that makes this process just a little bit easier to do this sort of seeing one tile at a time on a huge surface. Now, if you're passionate about utilizing one of these scenarios, you can ask questions at the end, a Q&A, or there's a great talk that was done in May that you can find online. Bing it. Okay. So now I'm going to switch gears just a little bit. I showed you some of the DirectX things, some of the fundamentals. Okay, so that's going to give you just a broad understanding, a higher level understanding of what needs to be done to get going with DirectX. Excuse me. I'm going to switch gears a little bit and talk about just the C++ specific stuff. So this is relevant to everyone in the crowd, but specifically, if you're not going to use DirectX, this is still relevant to you. So let's dig into some of the fundamentals. just by a show of hands, how many of you have created a desktop app in C++? Oh, good, good. And so for those of you who raised your hands, and maybe those who have heard of this, you have this thing called an H-wind. It's the handle to your window. And with the desktop, you also had this thing called, you had to create your own event, wind proc, and then you had this thing called the wind class. And that's all great and good. That allows you to set what your border of your window is and all that good stuff. But because the Windows Store environment is a little bit different from a design perspective, we abstracted a lot of that stuff away. And we now encompass that in what's called the core window. But if it's easier for those of you who have desktop C++ experience, you can think of it as like the new H-wind. Then there's this thing called the iframework view. So again, with C++ and DirectX desktop apps, you had to do all this fundamental setup stuff. Well, we've abstracted some of that away and created this thing called the iframework view. And I'm going to go into more detail of that right now. So the iframework view is essentially something you will implement. You're going to inherit from this class called iframework view, okay? Or it's in the templates or all the samples so you can view it there. But you're going to implement this, and you're going to overwrite 5 functions: initialize, set window, load, run, and uninitialize. Okay. Now, you might not have code in every single one of these, but what's happening is the operating system is going into, first, the initialize function, doing the application level stuff. Then you get your core window in the set window function, the set window method. And then beyond that, the load method, that's where, say, for instance, you're writing a Twitter application, and you want to do something where your application can be shared from another app. Load is the method that will tell you the parameter from where your app was launched from. The important takeaway from this slide, though, is this run method. You have 3 seconds to get here and start processing events. So the run method, that's where your rendering loop's going to be. And you will actually have an API. You'll make an API call called process events, and you have about 3 seconds to actually get there. Otherwise, Windows 8 will determine, oh, hey, maybe it's hung, maybe it crashed, I don't know. But it's going to terminate your app if you don't get here fast enough. So that's why you can do things like secondary splash screens to start processing events while loading all your assets. Now, this is sort of the code that's going to go into creating your framework view. So you can see here, we're inheriting. Okay? So you're inheriting from the iframework view interface, the class that exists, and creating your own framework view. And then you have this virtual void thing. I don't have to tell you guys, if you know C++, this means you're just overwriting those functions. But wait, there's something that's kind of tricky here, isn't there? What's this ref class thing? What's this little hat symbol? What's that shift 6? I've never used that before. Well, it's not an exclusive or anything that you may be thinking, but this is the new C++ component extensions. And when you'll use this, this is like the WinRT. This is like a WinRT pointer, okay? It's reference counted and all that jazz. But anytime you communicate with the operating system level, in this case, I'm getting parameters from the operating system. Those have to be WinRT objects, and I have to use the hat. Does that mean that your C++ code will not work? No, not at all. So the code you had on your desktop, there's other talks to help you port that, but you don't have to use these if you don't want to. Just when your operating system, when you're communicating with the operating system or cross-language, you can use these WinRT components. And then what's this ref class thing? Well, I'm creating one of these, essentially. I'm creating one of these things that you can use a hat with. Sorry. So how do you go about registering an event? Now, in an example of some events, some of the other talks maybe you've been to, they've talked about process lifetime management. Those are some examples of events. You have suspend, you have resume. Okay. And then you have window level events, things that are like pointer pressed, key down, when the window has actually changed size, maybe to snap view. Those are also events that you can register for. And there are so many events, but with the magic of IntelliSense, you can find them all. Well, and documentation and this talk, right? So one of the most important events that I think you all should be registering for at least is the size changed event. Now, the size changed event, that's going to happen, say, I'm using your great app, and now I go and drag it to my secondary monitor. This will be called. Let's say I grab your app and I snap it. This event will be called the size changed event. Now, because this is a core window event, we have this mWindow object that I got from the setWindow method that represents the core window object that I got from the operating system. And then I have this little ref new thing. Okay, you've seen ref class before. This is how you create a WinRT class, ref new. And then every event that you register for will have a typed event handler or an event handler to get the parameters for that. And so what I mean by parameters is look inside those two angle brackets. There's a core window WinRT pointer, and then there's the window size changed event args pointer. Well, when this size changed event happens, this method is going to be called, and this method that you write needs to have the same parameters that are in the templated arguments. So, how do you implement on window size change? Well, let me tell you. This is an example of how you would implement it. So you have those templated parameters, those templated arguments I showed you from before. Here you have the first parameter is a core window, and the second parameter is the window size changed event args. So again, an example is, the user has snapped your application. The user has gone from snap to filled with your application. So this is where you can do the snap specific checking. And here I show you kind of how that's done. But you should also do other things. Maybe if you need to, thank you. He's so kind. He's my boss. My boss's boss. You also need to do other things like resize your swap chain. Okay? If I dragged from a 1920 by 1080 monitor to something that's a little lower, well, you should be able to handle that. Okay? And you can do that down here. And then here's an example of doing the PLM, the process lifetime management events. So let's say I'm doing something like writing an app that's used for video processing. I'm on my desktop. I'm doing some processing on this video. I've gotten halfway through. Okay, I've added some cool effects to it. But now I go out for the night and I bring with me my Surface, or I bring with me my Windows 8 tablet, any of the above. And now I want to show my friend how far I've gotten on that video processing app. Well, now because of the magic of roaming and all that good stuff, which I'll get into later, you can do that. But the key here is if I walk away and I suspend by, for instance, I'm on my desktop and I bring another app into the foreground, it's going to get suspended. Here's where you'd want to save that data. And when I come back to that app, you want to resume where you left off, so here's where I would do that. So I've shown you quite a bit so far. And then the question becomes, how do you get going quickly? Well, there's some great Visual Studio templates. There's two that you can utilize. There's the Direct 3D template that is for pure C++ and pure DirectX, no XAML. Okay. Then there's another template you can utilize, the Direct 2D's template that has XAML support built in. And then, of course, there's dev.windows.com and using the samples. So what I want to show you right now is all the things I've talked about so far that have kind of gone into the C++ and DirectX template. So here I have Visual Studio open. and just going to File, New, Project. And under the Visual C++ Windows Store templates, you'll see the Direct3D app. And I'm just going to leave it as Direct3D app 19. I use the templates a lot, as you can tell. And I'll just go ahead and create that. So at first, you look at all the files and you're like, oh my gosh, a template has this many files? That's kind of weird. It's not that weird. The key file that I've been going over, the key things that I've been going over so far, are in Direct3D app 19.h and .cpp. That's the iframework view. Okay? So whatever you named your project, it's going to create that class for you. And then down here, you can see those 5 methods that are implemented in the CPP file to go with this class. And then below that, those are all the events that this template registers for. And then the one potentially weird thing to you guys is, okay, there's this thing called a cube renderer that's in the private variables here. Why is it there? Well, that's actually referencing this other class that comes with the template, the cube renderer class. Now, this handles all the DirectX setup. It handles all the drawing and all the rendering calls. And the reason why we did that is we wanted to separate the stuff that's C++ and not DirectX, that iframework view. Okay, we have that class. And then we have all the rendering stuff in this other class, the cube renderer class. You don't have to do it this way. You can combine it all into one. It's fine. But this is just the way the template does it. And it's important to understand how we did that. So what's this look like? Well, I'm going to go ahead and compile it. And it's building. And what you'll see when it pops up is you'll see the most basic Windows app that uses DirectX that you could submit to the store. And this will probably pass certification. You might get bad reviews, okay? But this will pass certification. Don't quote me on that, but I'm pretty sure it will. So now, you can review this template. You can go over all the things that I've talked about, all the registering events. But I just want to show you a quick example of how the operating system communicates with that iframework view. So here, I'm in my D3D app 19.cpp file. This is the implementation of my iframework view. And I'm going to go ahead and set a breakpoint in initialize and set window. And then I'm going to set a breakpoint in the load method. And then finally, the run method. Those are the 4 main ones. And then there's the uninitialize. Okay. But remember, that rarely gets called, so you can just generally leave that blank. So I ran this, and now what happened? The splash screen that I defined in my app manifest pops up. And then the operating system calls the initialize method. Okay, so here you register your application-wide events. Then it goes right into set window. Now you have your core window object. You have that. And you can do all the good stuff, registering events for that. Then load is called. So if you're going back to that Twitter example, you can check where the app was launched from using this entry point argument. And then finally, we get to run. And down here in run, what I want to point out is here's where that process event API call I pointed you to earlier is. So I have 3 seconds to get here. It's a little lenient when I'm debugging, right? But you have 3 seconds to get here and start processing events. And boom. So let's switch back to the slides. So I just showed you the fundamentals of DirectX and the fundamentals of C++ and how that goes into the template. But the template's kind of boring. It's a spinning cube. It's got colors. It doesn't even have its own splash screen. So what I want to talk about now is I want to talk about this, how you can add Windows Store app features using C++. So I'm no longer talking about XAML. I'm no longer talking about DirectX. I'm talking about C++ ways to implement live tiles, toast notifications, to make your template go from this boring spinning cube to this great thing that those design people will love. Okay. The most important thing, potentially, is live tiles. And I say that's important because after I run, as a user, after I run your app for the first time, you're going to set up some sort of live tile so that next time I go to the start screen, I'll be able to see, I don't know, the high scores for the game that I've played so far, or whatever you want to do with the live tile. So here's the code on how to do that in C++. It's essentially an XML document that you send to the tile update manager. And boom. Now, something that is very related to live tiles when you look at the C++ code is toast notifications. I'll get into that in a sec, but first, let me just mention that, oh, by the way, when you create these live tiles, make sure you use one of the predefined templates so that it doesn't look weird, or it goes with the Windows 8 guidelines. So when you set up your XML, you can set the template like so. I'll take questions at the end. So toast notifications. I was really excited, so I got into that a slide early. Toast notifications are great, and we make it easy for you guys, especially if you've already created your live tile using that C++ code that I showed before. There's not much that has changed here. The XML has certainly changed. Now, instead of a tile XML, you have toast XML, right? But instead of the live tile update manager, now you just update the toast notification manager. Okay, so why do you care? Why do you care about toast notifications? Well, let's say I'm playing this game, and let's say it's Marble Maze. I'll show that shortly. And I get to the end of the Marble Maze, and I get this great high score. And in fact, I beat all of my friends in the world at this game. Boom. Achievement. Don't get this confused with Xbox Live achievements. That's a little bit different. This is something you do to make the user feel, happy. They got an achievement. How cool is that? But there's other examples. And I leave it to you guys to design those other examples, right? But if you like your toast in the morning like I do, you can do that too. So you have this thing called scheduled toast notifications. And I'm illustrating this here. So say you have this great new in-app purchase, or you have this, you say you're making an online game, for instance, and there's some big event that's going to happen at a certain time. Okay? You can make sure that that event happens at the user's machine at that specified time. Now, the one caveat, all the people I've worked with who have tried to implement toast with C++ or other languages, they forget to declare toast in your app manifest. So your code, your C++ code, it might be beautiful, but make sure you declare toast in your app manifest. So you've decided to use pure C++ and DirectX for your app. Now, how do you register for the app bar event? How did Fresh Paint do that? Well, you know what they did. I know what they did. They used the edge gesture completed event, and they registered for that. So because you're not using XAML, you have to draw the app bar using Direct2D. So you can register for this event, and then when I go to get my paint options from, say, Fresh Paint, you draw that cool little canvas thing and the paintbrush selector using Direct2D. Boom. Here's an example of how you'd register that. Now, it's no different than registering for any other event, other than maybe now you have this edge gesture class that you're referencing. And so one key thing you need to think about when you're actually drawing this on your own, make sure you check the device orientation. You don't want to draw an app bar that's going on landscape when they're actually holding in portrait mode. So that's one thing to consider while you're doing this. One of the things that can help make your app go viral is the share charm. Here's how you do that. You're using the namespace, or this class data transfer manager, and you're using this namespace, the data transfer namespace. And then when I go on the right side of the screen, swipe in from the edge, and grab that share charm, and press on that share charm, this is what's going to be called. And so what that might look like is you'll have the title and the description, high score, my high score, after they press the share charm. Now, let's say I click on mail or email. What you'll see is the text that I've set. Now, how do you do settings? Well, same thing. You click the settings charm, and you register for that event, just like so. And what's going to happen when I click on the settings charm, this method will get called. So whatever's in here is going to populate my settings menu. Now, why is the settings menu important? Well, you want to say you're writing a game again, or any other app, and you want to have some audio control. What you might do is you might register the audio command, or this command right here, to represent audio. So then when I swipe in from the right, or from the edge, I get this cool menu that looks like this. What's that mean for your application? Well, I can now go click audio, and then you can, using Direct2D, or if you're using XAML, you can render an audio panel or video settings panel. Oh, and by the way, if you use the internet, a privacy policy thing should be there too. So here's the rest of that code. So for each of those commands I registered, you just have your own method. In this case, I'm writing an app that I want to conform to the Windows 8 guidelines, and I want it to be, I want this thing that comes in from the side, this panel that comes in from the side. So using Direct2D, I can draw this. And there's a great sample on MSDN that shows you how to do this. And of course, you can use these slides once they're posted online. Now, the final thing I want to talk about, going back to that video processing example. Okay, I'm on my desktop, and I process halfway up to the halfway point in that video. Now I'm going out to the bar, hanging out with my friends, and I want to show them what I've done so far on my tablet. Well, what you can do is you can use this to save this namespace to save data, and you can even make it roam that way. So here's how you do it on the local machine. So this is something that wouldn't roam. Okay, this would be something I'm on my desktop editing this video. I leave for a bit, then I come back to the desktop, and it picks up right where I left off. So here I'm saving the time that I left off when editing that video. Now, it's an easy change if you want to make this roam. Boom. Did you see what I changed? I changed this right here. There's a caveat here, though. Now that it's roaming, there's some space restrictions. So you want to keep this limited. 100K is about the limit for roaming data. And there's this thing called high priority data that has a limit of 8K. All right. So as I was browsing Channel 9 after Windows 8 launch, there was all this cool stuff that was coming about. All these cool videos. I started one even. I noticed the most popular video was this, how to make money with Windows 8. That's what you guys care about. So I wanted to just take these two slides to just introduce the topic and how you do that in C++. So when you're creating your application, your Windows Store app, on the dashboard, you're going to see something like this that allows you to set the price point, that allows you to set if you want a trial or not. Now, you should have a trial with your app if you're going to have a price point, because that's going to increase your revenue. And in fact, there's a blog by the Windows Phone people who have had this trial thing in place for some time, and it increases your revenue quite a bit. So let us handle that. But if you want to have a feature-differentiated demo trial, you can also have some features be bought in your app using this API. So let me just walk you through a demo of this game called Marble Maze. Now, how many of you have heard of Marble Maze? How many of you are sick of hearing about Marble Maze? Okay. Good. Well, that's why I've added those great Windows Store app features to make it really stand out. So let's say I'm creating an app. I'm using a game as the sample, but it doesn't have to be a game. It could be anything. And I have the trial version. Okay? And I'm the end user, and I'm playing it with touch, with an Xbox controller, or whatever input device I want, because we had that consideration with this sample. But because I love the game so much, I want to give back to the developer. I want to buy the full version. Okay? So I can swipe up from the bottom, from the edge, and I'm drawing an app bar using Direct2D. I can click this Store button that I programmed in, and I can go over here and click on Buy Game. Now here's the store simulator that you'll see with C++. This allows me to simulate all the bad things and the good things that happen when an end user is using the Windows Store feature, the Windows Store API. So you can, if the end user is out of memory, you can catch that exception and go from there. But I'm going to make it so everything went OK. And notice the trial pop-up, that's gone. That could be an advertisement. That could be whatever you want it to be. But now I've bought the full version. I'm no longer on that 7-day trial. I'm on the full functional version. And now, because I love this game so much, I can go ahead back to the store panel that I drew, and I can buy an extra texture for my marble. Okay? So I'm going to go ahead and do that, and oh my gosh, how cool is that? Now I have this different texture on my marble. So this is kind of how you can make money, right? Now another feature I know that comes with the full version is this thing called superpowers. Okay? I'm going to swipe in from the right, go to Settings, and oh, there it is. Enable superpowers. What's that? Let me check that out. All right. So I enabled it. Oh my gosh. It allows me to cheat, right? And because I did so well, I got the highest score. In fact, the only high score since running this app. A toast notification popped up that said, "Hey, guy, you did a good job." In fact, I got the World Domination Achievement. And you know what? I did so good that I want to tell my friend Shai. You know what? I'm going to go into the share charm. I'm going to share this with my buddy Shai. And boom. Well, sending email and then boom. So now Shai is going to get this high score email, and he's going to be like, oh, you know what? I can beat that. He doesn't know about superpowers yet. He's going to go play the game anyways. You know what? He's going to get a score that doesn't quite beat mine, but he's going to tell all his friends by sharing. It's going to make your app go viral. Whether it's a game or not, it can go viral that way. Now, I've been talking about these Windows Store things that you can implement with C++, but I haven't talked about live tiles. So here, with Marble Maze, I added this live tile that shows you just some hard-coded high scores. Now, for you guys, that could be something that's populated from Azure, something that you do dynamically that you get from the internet to show, hey, the top player is beating you. Come play my game. Okay. So I just showed you a demo that encapsulates everything there is from DirectX fundamentals, C++ fundamentals, but also the Windows Store features. And it was all done using C++ and DirectX. And so that's kind of the wrap-up. So the summary of everything that I've talked to you about, fundamentals of DirectX. How do you do from a just high level, how do you do the DirectX stuff? And then from a high level, what's this thing called the core window? What's this thing called the iFramework view? And I've even given you some code. So after build's over, or whenever these slides are posted online, you should be able to just use this, and boom. Maybe I'm saying boom too much, right? So here's the other resource you can reference. And the call to action for you guys, you have this template that is essentially a Windows Store app, okay? But it's a boring Windows Store app. Go out, go make this template great. Go add these Windows Store features using C++, using DirectX, and if you have more questions, there's resources. Questions? Thank you. So for those who have questions, let's use the microphone in the middle. So just create a line, and we'll go from there. And anyone, if I can't get through all the questions, I'll be in Rainier, and you can network with me and ask questions there too. Yeah, person in the front.
Can you show anything about Direct 2D? Everything was Direct 3D, and our application is a 2D graphics application. So
I apologize. That's my bad. So
yeah, this was a DirectX.
There's lots of samples that utilize just Direct 2D.
Can you show that template here? The other template?
Yeah, why don't we take this offline, actually? Just find me once Q&A's done, and we'll go from there. So yeah, there's a template for that, and then there's also quite a few samples. So.
Will your updated marketplace, Marble Maze, be available for download anywhere?
Eventually. So we're going through the process to make it a full sample. Yeah. I don't want to give an estimated date, so that might take time. But.
For the notifications, C# has a tile notification template and toast notification template enumerations that you can get the standard text XML for that. Does C++ not have the equivalent?
Is your question, does C++ have templates available?
No, have the enumeration to get the template already, so you don't have to explicitly say, you know, this is the tile, this is text 1, text 2, image 1.
So there's a sample that utilizes C# and C++, and that shows you how to do that kind of thing with C++. So I'd point you to that sample, and in fact, it's hyperlinked in the slides. It's a snap sample.
The live tile sample?
Sorry, not snap sample. Yeah, live tile sample.
Okay. Does it have the enumeration in there? Does C++ have that capability to just have that string?
Let me leave that as an I don't know.
Okay.
And but I can find the right person who knows that answer. How about
Thank
that?
you.
Next question.
So when you said you can use DirectX and XAML together for your app, how does it affect the battery performance? Do you
So your question is, if you use DirectX with XAML, how does that affect performance?
Right.
Good question. And let me first start by saying I'm not the expert on that, but there's two other great talks. But it shouldn't affect the performance really at all. In fact, if you find any performance difference, maybe it's because you're doing something that's too intense in XAML, or maybe you're doing something that's too intense in DirectX. But that combination, that won't slow anything down. That shouldn't slow anything down.
So is it that XAML is more CPU-based, and then DirectX would handle the GPU, and so both CPU and GPU would be working at the same time, or do you know anything?
It's something like that, but again, I'm not the expert. But
okay, thanks.
So.
If you're using a purely DirectX context, and you bring up the settings menu, did you say you have to actually render all of the different views that come up in the, I guess the bar that slides over is still the Windows 8 bar, or are you actually rendering that?
So your question is, what do you have to render using DirectX when you bring up the settings?
Mm-hmm.
So what you do have to, what you don't have to render is when I was doing that Marble Maze sample, I swiped in from the right, I hit settings, and it showed the enable power, superpower thing. That is all done using the C++ code that's in the slides. Now, what you would have to render is in that audio sample in the slides. I clicked audio, and then this audio panel came up. Now, you would have to render that yourself.
And what kind of, what kind of element is that?
What kind of, sorry?
What kind of, is that a different view that exists from the main window that you're rendering?
Is that related to the core window? Is that your question?
Yeah.
Yeah, so kind of. So remember, DirectX is bound to your core window.
Mm-hmm.
And so what you're going to actually do is you're going to reference the Direct 2D context to actually draw a rectangle, for instance. Does that make sense? Does that kind of?
Yeah. Are there examples that include rendering that and also the app bar?
I know there's examples that utilize, or there's at least resources that you can find to learn about how to register the edge gesture event. Maybe let's take this up offline. I don't know if there's anyone that actually renders using Direct2D a app bar.
Okay.
So, next question? Any other? You guys got me for 10 minutes, so if you have questions. Yeah, sure. Yeah, let me bring that up. And if you guys have more questions, I'll be up here for a few minutes.
How are you doing? Good to see you.